Welcome to the first video of the What Should I Watch While Eating series. For centuries, humanity gazed at the night sky with awe. Ancient civilizations crafted stories and myths to explain these celestial bodies. They saw them as gods or omens. Early astronomers like Ptolemy tried to map the stars. They made models of the universe with Earth at the center. Their geocentric view dominated for centuries, but their models were imperfect. In the Renaissance, Copernicus proposed a heliocentric model. He placed the sun at the center of the universe. This idea was revolutionary. However, it still lacked precise explanations. The world needed a genius to unlock the secrets of the universe. Isaac Newton was born in 1643 in England. One day, as the story goes, he saw an apple fall from a tree. This simple event sparked his imagination. Why did the apple fall straight down? Newton pondered these questions deeply. He realized that the same force pulling the apple to the ground also affected the moon. He called this force gravity. Newton's curiosity led him to experiment and observe. He formulated the law of universal gravitation. Newton published his findings in 1687 in the book Principia Mathematica. The cosmic clockwork was starting to be revealed. Newton's law of universal gravitation is elegant and powerful. It states that every mass attracts every other mass. The force of attraction is directly proportional to the product of their masses. It is inversely proportional to the square of the distance between them. This means that larger masses exert a stronger force, but the force weakens rapidly as the distance increases. This law explained why apples fall to the ground. It also explained the motion of celestial bodies. The moon orbits the Earth due to gravity. The same force keeps the planets in their orbits around the sun. Newton's gravity became the cornerstone of classical physics. His law of gravitation also explained the tides. Every object, big or small, is part of the grand cosmic dance. Let's dive into Newton's laws and planetary orbits. Newton didn't stop at gravity. He also formulated 3 laws of motion. These laws describe how objects move. The first law states that an object at rest stays at rest. An object in motion stays in motion unless acted upon by a force. The second law states that the force on an object is equal to its mass times its acceleration. The third law states that for every action, there is an equal and opposite reaction. Newton's laws of motion, combined with his law of gravitation, explained planetary orbits. Planets move in elliptical orbits around the sun. Newton showed that these orbits are a result of gravitational forces. His equations could predict the positions of planets with great accuracy. The cosmos was now predictable and understandable. Is universe predictable? Newton's discoveries brought a new level of predictability to the cosmos. The universe was no longer chaotic. It was a vast clockwork mechanism. Every motion followed precise laws. This predictability was a triumph of human intellect. Newton's work laid the foundation for modern astronomy. Scientists could now predict solar and lunar eclipses. They could chart the movements of planets and stars. Modern space exploration builds on Newton's principles. Spacecraft navigate using his laws of motion and gravitation. The quest to understand the universe continues, inspired by Newton's genius. Subscribe for more cosmic stories.